Alright, howdy everyone. Back again for week 2. Looks like there's a few people online, so we'll go ahead and get started. So last week we left off with the PCB design, and it still had a ways to go. So I went through and went ahead and finished all that out. Went back to the drawing board a couple of times on the layout, but ended up with a pretty good routing here. So, one decision that I made, kind of based on, sorry, the zoom in KiCAD. One decision that I made was the placement of the USB port. Because of the way the sockets are situated, the USB port would have had to stick really far out the back. So I decided that we would just put it on the side. There's not a lot of keyboards with a side USB port, but if you're using it with your laptop or something, it really makes a lot of sense. So went ahead and went with that. Added some logos, text, a little bit of stuff in here and cleaned up. Made sure all the labels were visible. None of them were overlapping other labels. Oops, wrong button. And so went and made sure that all of the silkscreen labels were visible. Mostly right in here around the controller. Everything's visible, nothing's overlapping anything else. And I sent that off for manufacturing last night. So hopefully those will be here by next week. If not, then I will just switch up the order of the stream, and we'll do the CNC next week and the PCB assembly the following week. So now, case design. Should go a lot more smoothly. It's pretty straightforward. I kind of have it down to an art, down to a science, I would rather say. So the first thing I did is I exported a step file from KiCAD. This is a new feature in the nightly builds in KiCAD 5, and it's really quite convenient. Previously, I had to export this IDF v3 and then go through a website called ecad.io. Then I could get that board outline into Fusion 360. Now I just export that step file, come over to Fusion. You can see I've already imported it. So all I did here was say File, New Design from File, pick the step file, and it came in, looked like this, saved it and gave it a name. And then it's over here, and I came over to Insert into Current Design, and there you go. Now it's right in my current design. So we'll go ahead and close out of that side panel. And sorry, one window. Here we are. We have PCB. That's step 1. So if you look at the Cherry MX datasheet, all of the features of the switches are referenced from the top of from two places, from the top of the PCB and the top of the plate. So what I like to do is come in here and make a few construction planes to help make things easier. So I'm going to make a construction plane on the top of the PCB, even with the top of the PCB. That's going to create this construction plane over here, and I'm going to go ahead and rename it PCB top so that I know what it is. Then I'm going to make another construction plane. I'm going to offset it from that one, and I'm going to offset it 5 millimeters because according to the data sheet, it is 5 millimeters from the top of the PCB to the top of the plate. I'll call that one plate top. Okay, so that's really the main 2 dimensions that you need. I will define a couple of others as well, just so that I can get everything like I want it. The next one I'm going to define is also going to be from the PCB top, and I'm going to have it come down, so it's going to be negative 1.6 millimeters. That's the thickness of the PCB. That'll put us at the bottom of the PCB, and then I'm going to make parentheses around this, or the come out to the right number. And then I'm going to go down an additional 3 millimeters. And that's going to give me, not 33, 3 millimeters. That's going to give me enough clearance for, let's see. It doesn't like just arbitrary expressions. It has to be inserted from it. Okay, so that's going to give me, you can do expressions here. You don't have to do you don't have to do the math ahead of time. You can leave the math here. So that's going to give me the inside bottom of the case. That's 3 millimeters is enough clearance for the components on a surface mounted board. And that's what you'll typically see, and that's going to look something like this, right? That's what you're typically going to see on most case designs if you measure those. The other dimensions that we want to define are going to be the bottom of the piece of the case, which is going to be based on how thick I want the case to be. So I'm going to define that from the inside bottom, and I'm going to say, again, that's going to be negative. I like to make my cases pretty thick, so I'm going to give that 6 millimeters. That's a fairly thick bottom. That's kind of as thin as I like to go with wood, since we're going to be making this out of wood. If I was going to go with aluminum, I'd probably get away with going down to like 3, but I still like to make aluminum kind of thick. I'm actually going to make this a little thicker. I'm going to go ahead and make it, because I am going to put an angle on this case, so I am going to go ahead and make this 10, so it'll be nice and thick from the bottom. So that's going to be the case bottom. And then the last plane I'm going to define then is going to be the top of the case. So if it's a low profile case, it's going to sit flush with the top of the plate. But in this case, we don't want to do that. We want to come from the plate top, define a new plane, and that's going to be the sides of the case, right? So a high profile case is typically about 7 millimeters minimum. I want to make this one a little bit higher because I want it to be kind of a little bit higher profile. So I'm gonna go with like 8.5 millimeters. It's pretty good distance. So this is going to be case top. Okay. So now I've got all these defined, and just to kind of hit escape to get out of whatever I clicked on. Just to kind of give them an idea of how thick this is going to be, I'm going to measure from the case top to the case bottom. I have to hit the inspect and measure from the case bottom to the case top. Case top, case bottom. There we go. 28 millimeters. That's not terrible. And again, I'm going to have it angled across the front, or from front to back. So the front of it's going to end up smaller than that. So I think that's going to be a pretty good size. Okay. So I'm going to go ahead and hide all those because they get in the way. The nice thing about them is I can always reference them from over here in the side menu. So I'm always able to get to those when I need to define something, as you'll see in a minute. Okay, so the next thing we're going to do is we're going to make a sketch to define what the case is going to look like. This is going to be the inside of the case. So we're going to do the new sketch. I could click on the top of this PCB, but if I do that, you see there's an outline around each of the little holes. It's going to project every one of those holes onto the board, onto the sketch, and that's a lot of holes that I don't need. So what I'm going to do instead is I'm going to pick PCB top as my plane. And now I'm going to project, I'm going to hit fit to fit this into the window, and kind of minimize some of this stuff up out of the way. I'm going to hit project to project just the features that I care about. That's going to be the object. It's going to bring up this window. And then I have to be careful not to hit the entire surface, because if I do that, again, it will project every one of those holes. So I'm going to pick the edges. Sometimes I got to zoom in to get these smaller ones. And just work my way around the board. radius here. I don't think it's that important to do that. You'll see here in a second that I have some of the components with 3D models modeled on the bottom of this PCB. I didn't have them all defined when I exported this, so I don't have all of them. In particular, I don't have the sockets and I don't have the USB port. I purposely didn't define the sockets because with that many sockets included, it makes Fusion 360 really, really slow. I intended to include the USB socket, USB port, because we will use that for referencing where that port's at, but I'll add that in here momentarily. Okay, so now I've got everything projected. No, I don't. Let me go back here. Let's fit this to the screen again. I forgot the mounting holes, so those are important as well. So there's a mounting hole. They're these smaller ones that are just kind of off by themselves. They're made to screw the PCB to the case, and they're going to be 2.5 millimeters in diameter to fit them in 2 screws. So I just got to find the right one. So that looks like a hole right there. Okay, there's 8 of them total. I'm going to try to keep the chat where I can see it over here, so if you have any questions, feel free to ping me in chat. I see one message. Is anybody active in chat? Maybe I'm not on here yet. Just respond if you can leave a message in chat. It'd be helpful to make sure I know that you're able to get that. I don't have anyone here helping me read the chats and such tonight, so just you know, maybe ping me if you have any questions. Maybe you'll know if I'm pencil holder. I thought about that. Somebody posted a picture yesterday of a case with a pencil holder, and I thought it was, I've seen it before, but I thought it looked like a pretty good idea. I may do that. I will not have cup holders, unfortunately, or fortunately, whichever way you want to look at it. No offense to those who like cup holders on their keyboards. Okay. I can see what all I have here in my sketch, and you can see that I have everything. Okay, so the first thing I want to do is I want to create an offset. So if I make the inside of the case the same size as the PCB, then it's going to have problems fitting if I don't get that machined exactly right. So I like to leave a pretty healthy margin around the PCB itself. O is the command for offset. If I include this chain selection, it should have picked up all of those around the edge, but it didn't. So now I'm going to have to go back and select them individually. Once again. And I'm going to go ahead and offset this to, you'll see why later, even though it seems like it's going to stick out, but it's not going to stick out the entire way around. So. Okay, and 1 millimeter I feel like is a good offset. That gives me 1 millimeter in any direction, so that's a pretty good offset. It gives me plenty of space. I've used larger margins in the past, and well, you know what, I'm going to go ahead and give it 1.5 just to make sure we have plenty of space around it. But we should probably be fine with 1, but it can't hurt to have a little extra space inside the case. Since we're gonna have, it's not going to be visible. If I'm trying to make it real tight, then I'll keep those really constrained, but in this case, I'm not too concerned about. So you can see the locations of our mounting holes. I tried to distribute them fairly evenly. This is where the controller is, and you probably can't see my cursor moving around. So let's see if we do this. Oh, no. Okay. Used to have the thing where if you pushed a button, it would put circles around it, but I don't see that. So this area on the top left where there's kind of some gaps is where, oh, you can't see my cursor. Okay, never mind. This area is where the USB controller is at, and so I didn't have room for any screws up here to make it even, but I put it over here by the USB port since you're going to be plugging and unplugging that. It was a good place to have that. So obviously this will not fit any existing cases. I don't really have a problem with that since this is going to be a custom one-off deal. So if I was going to try to make it fit a 60% case, I could obviously get those hole mappings, but I put my port on the side, so that kind of eliminates that anyway. Okay, let me think. Okay, so now I'm going to go ahead and do another offset. So this is going to be the inside wall of the case, and now I need to do the outside wall of the case. What you'll see happen here, if I click offset and try to pick this outside curve, it's going to give me an error. It's going to tell me that it's already been offset, and maybe I want to offset from the original line instead of this new one. I'm just going to ignore that warning. It's really just a warning, even though it calls it an error. I like to have a pretty thick bezel on the case, and I know that I'm going to be adding some stuff to the top. Normally I use about 10 millimeters. That gives you a pretty thick bezel. In this case, actually, yeah, I'm going to go back and change this. Okay, so I'm going to zoom in here, do one thing. I'm going to draw a line. Click L to draw a line. I'm going to close off this space right here. And then I'm going to offset from this line. See, this is why I want to use the other one, because it's going to make me go back and do it all this way. I don't want the outside of the case to follow that same contour, so that wouldn't make any sense. So I'm going to do the outside of the case, and again, I'm going to make it 10 plus the 1.5 that I had originally offset. So that's going to take it out there, and then I'm actually going to change that. That's what I would normally do, but in this case, what I want to do, I know that I'm going to add a piece to the top because we have those blockers, or we have those corner keys where we need blockers. So I'm going to be adding blockers. Yeah, let me answer these questions real quick here. So, yeah, so I'm going to be doing this case. At least the first prototype, I'm going to be doing CNC, just like the other cases that I produce. It's going to be made out of wood. Sorry, I'm jumping around here. It's kind of lost where I was at. Let's see. It's confused about that. Fusion doesn't really like when you switch to other windows sometimes, so let me go ahead and finish all this out, and then I'll. So I'm going to make this 12 millimeters. Is what I was. Oops. With all the pieces. What I was getting at earlier is I was going to make this 12. So I was looking for my pen. Is this here? There it is. Okay. And in case you were wondering, if you are interested in buying one of these, they will be for sale. I will have the PCBs in next week. So if you're interested in buying a PCB, I will probably have something up on the website later this week that you'll be able to purchase one of those, as well as pre-order the case after you see the design here. Okay, so that is the whole way around. So that gives me a 12mm bezel. I'm going to give it just a little bit more. Go ahead. I'm going to push it out. It's going to be a pretty big bezel. I'm going to push it out to 15mm. And the reason for that, which is what I'm about to do right now, is I'm going to add a piece on the top that's going to be the blockers, and ideally that will be machined from brass. In the prototype it would most likely be or not machined from brass, but laser cut or water jet cut from either brass or stainless, or even aluminum. In the prototype it's going to most likely be acrylic. We'll go ahead and just leave the case at this for right now. We'll get the basic case design and we'll start adding some of these other features in later. So we're going to stop it right there. You remember the PCB sits flush with the top. Yes, I did this at the top of the PCB. Okay, so we want to actually, I'm going to go back into that sketch for a minute. And so you just double click to go back into the sketch and continue editing. So there's a couple of things that are going to make this a whole lot easier. If I change these original lines and I press X, it changes it to a construction line. And what that means is that no longer defines a. You'll notice that when I hover over these sections, it highlights a section. And it was highlighting these individual sections here until I turned these into construction lines. By turning these all into construction lines, it's no longer going to select. It's going to let me select all of this at once rather than having to select it as individual little pieces, and that'll be easier when we get over here to the building up the case using the extrude tool to extrude it and then cut out. We'll do a combination of extruding stuff and cutting other stuff out of it, mostly using this one sketch that we defined here. So that's all those. Okay, and then the other thing I want to do is these circles, as I mentioned earlier, are 2.3mm in diameter. So that's not the diameter that I need in order to do anything in the wood case. So what I need is a 3.1mm diameter hole, and that's going to be what I insert the brass inserts into. I've got some of these right here. See if I can show these. I don't know how well it's going to zoom in. So there are these small little inserts. They're brass. They're kind of they're called knurled on the outside. They're rough, and you press them down into the hole. They have threads on the inside that you can then screw your standoffs into. So what I'm going to do here is I'm going to unselect everything I have selected. I'm going to press C for circle, and I'm going to define a circle that's at the same center point here, and it's going to be 3.1mm. And then define that. Okay, so now when I go to do this extrusion, then the holes are going to be the right size, and I'll have to adjust them later. So I'm going to go around doing the same thing here, turning that to construction, selecting that to 1. Do it backwards. And again, it's just a matter of zooming into each one. Sorry if you're watching this video, you kind of see it's like it's just all those in there and out. What I probably should have done here is go ahead and define a parameter so that I'm not typing this thing in, because then if I want to change the hole size, I could do it all at once. So let me go show that real quick just to show you what I'm talking about here. So I can make a user-defined parameter. I'm going to call it hole size, and it's going to be 3.1 millimeters. Okay, now down here in this sketch, all of these hole sizes, I can change them all, and instead of 3.1 millimeters, I can say hole size. And now if I go and edit that, it's going to, oops, that's not moving. That's extruded. Sorry. Go back into the sketch. If I click on the dimension and I double click that, it says hole size as the dimension. So now I'm going to do the same thing on the rest of these. I'm going to create a new circle, and I'm going to say hole size as the dimension. And you'll see it'll make it 3.1 on its own. I like to drag these so something. Okay, that's right. Drag those out so you can read them so they're not overlapping. I don't always do it, but it makes the sketches clean. On to the next step. These parameters that I'm doing here, this is one of the things that differentiates Fusion from some other modeling programs, because Fusion is a parametric modeling, so that means that everything is parameterized. You need to have everything have a dimension in order for it to be well defined. And so each of those parameters then is configurable, and you can go back and you can change those parameters to change the way your object is defined. Whereas some other programs, you're building things up from curves and different things. I didn't use hole size parameter on the hole. Which one? Yep, you're right. So this one says FX and that one doesn't. So you're right. I typed in 3.1. There you go. Thank you. Okay. So stop sketch. Go ahead and hit save here. Okay, so now we want to build up the case. So the first thing that I usually like to do is to extrude everything here. So we're going to hit Q, which is press pull. It's kind of a generic. There is an E for extrude. If you press Q and you select a feature here, then it's going to bring up the extrude dialog. If you pick a different feature, then it'll give you different functionality. I need to make sure I pick all the holes here. So you can see how if I had extra little sections defined over there where I had all those extra little lines, this would be really cumbersome, and I would have to pick up lots of extra little polygons when I did this. So now we're going to go from object, We're going to start at the case bottom. And then we're going to go to object. And we're going to go to the inside bottom. Okay? And that's going to make a new body. So you can see that we defined a little object here. And if I turn the PCB back on, you can see that it is floating 3 millimeters above that. Okay? Now, we're going to finish the rest of the case. So we're going to have to turn this sketch back on. So the first time you do it, here. All right, I'm going to have to pause for just 1 minute, so I'll be back momentarily. So. And we're back. Sorry about that. Okay. So we turned the shape back on, or the sketch back on, so we can see the rest of the lines here, and we're going to pick up the just this outside line. So we're going to hit Q again, press pull, and again we're going to go from where we picked up the 4, which is the inside bottom, and then we're going to go up. Oh, sorry. We're going to pick from object inside bottom. Now we could specify a distance here, and we could just make this, however tall we wanted and specify it there. But it's a whole lot easier if I want to go back and change things to just change the definition of these layers, these construction planes. So we'll make this go all the way up to the case top. We're going to join that to make a single body. It doesn't want something. Interesting. Let's just clear everything out. See what is the problem. So we're going to select the profile. We're going to select this piece. And we're going to select the from object. We're going to select inside bottom. We're going to select to object. We're going to go case top. So let's just make a new body and see what happens. Okay, that's bizarre. I've done this like a half dozen times here already. Many issues. Yeah, sometimes it just does weird stuff like this. I've seen it. Possible I picked a plane. Yeah, that is a very Fusion thing to do. It probably got an update and it probably broke my favorite feature here, so yeah, let's see. Well, yeah, we'll just make it a distance, I guess. And see what it knew exactly how high I wanted it to be. I wanted it to be 18.1. So that's kind of my workaround when stuff doesn't do what I want it to. I pick the 2 object and then just change it back to distance, and it fills in the distance for me. So we'll just leave it like that. Okay. So that gives me my basic definition of what the case is going to look like. And then we got to come in here, we got to add a couple more things to get it nice and well defined. So the first thing is going to be the holes that I mentioned. So we're going to then do another operation. We're going to pick each of these. Let's go ahead and hide the body. Pick each of these holes. I'm just kind of tedious. And this one I usually don't define a parameter for, but I'm going to go down 3.2 millimeters down. Minus 3. We're going to turn the bodies back on, and then it's going to. Okay. Except instead of from the profile plane, again, we're going to go from object. That's going to be the inside bottom. Now we're going to cut that. Okay, so then we can turn the sketch off. And we have holes for the inserts. We'll go ahead and instead of looking at steel, we're going to change this to look at walnut. Make these nice pretty renders. Just this bottom piece. Tool body, which is this top piece. I'm going to join them. I don't want to keep the tools. And so then there we go. So now I have the case and the basic design. Yeah, already starting to look like a case. Pretty much the only thing left to do to make it into a real case would be to cut out the USB port. And then it could be a functional case. The one thing that's, sorry, trying to get back to the chat over here. Okay, there we go. The one thing that's missing here is, I mean, the next thing we want to do, see, it came with a whole lot of components. It brought in all the diodes, and it brought in some other chips. It did not bring in, doesn't appear to have brought in, yeah, that's just the PCB itself. So it didn't bring in the USB port, and that's, like I said, the one thing that I kind of would like to have in here. So we're going to add that. I happen to have the USB port defined over here amongst all my other garbage. I think it's in here. Nope. So it's not the USB-C then. Okay, that's all right. We will go ahead and bring that in. I'm going to make sure everything's saved. Close out of this other one because I'm not using it. Well, actually. Okay, so new design from file. I'm going to get the part, and I know where I have it located, which is in my GitHub library for keyboard parts, pretty KiCAD. And it is this I think it is. I think it's that. Yeah, that's it. Okay, so that's the USB port, and I'm going to save that, and I'm going to put it in the folder where I thought it was, parts, and then we're going to save that. It's been a USB port. And double click on that. Come back over here, and then I can right click and insert it into the current design. Okay, when I bring it in, it's just in some arbitrary orientation. I need to get it into the correct orientation, which is going to be on the bottom of this PCB. So that's where we want to kind of be. Rotate this whole thing around so that we look at the bottom. The right rotation angle here. Make sure I get to 70. There's a couple of ways I could do this. At this point, I'm just going to kind of eyeball it. Should get us close enough. It's got these alignment pins that you see on the back, which are going to help me get this thing aligned properly, just like they would on a real PCB. So you see there, I'm sunk in, so I don't want to go quite that deep. Make it like I'm looking right now. Yeah, for some reason I have a perspective camera turned on, which is not what you want when you're working with. That looks like I'm on the surface. Now if I roll around to the bottom, I'll be able to see when those pins line up. That looks pretty close. Let's see where that port's defined. Yeah, it looks really good. Okay. So we're going to go back home. We're going to turn the case back on. Now I need to make two sketches. One of those sketches is going to be, we're going to need to cut a little recess where that USB port's going to go down into from above. And then we're going to cut a hole in the side where the USB port's going to cut out. We're going to put the cable through. So we'll start with the easy one. That's the one from the side. Well, I say it's easy. That's the road that's same. Okay, so I'm going to define a new sketch plane. I'm going to use the end of this case. And again, that is going to bring in the whole rectangle. Then I'm going to go ahead and turn this body off. We're going to project kind of this outline of the USB port. So you see we have that face right there. That's the outline of it. I could get all fancy and I could project and I could cut it out in that shape, but that's not what we're going to do. So I'm going to take all of this stuff I just defined and I'm going to make it a construction plane. And then I'm going to take it, I'm going to draw a rectangle, R for rectangle, around Yes, I'm going to turn that PCB off so it'll be easier to see what we're doing. Okay, so we drew a rectangle. Oops. Now we're going to add a dimension, so we're going to add an offset from here. So from there to there, again, a 1 millimeter. This one's, well, we don't know if it's exactly right, so we're going to go ahead and make this 1. Well, that looks way too big. Let's see, I may make that 0.5. It's a little more realistic. Not 5. That would be a really ridiculously large USB port. Okay, so that's pretty reasonable for kind of the tight spacing around the USB port itself. And then I want to make another rectangle that's going to go around that. And I'm going to, well, actually it'd be easier, I'm just going to offset this rectangle. I'm going to go out, and I'm going to make it 2 millimeters. Should be a pretty good size. It's probably a little bigger than it needs to be. We can tweak it if it looks bad. Okay, we're just trying to get something mostly quick here, and we can come back and use that later. So turn the case back on. I'm going to hit Q to project, and I'm going to take this one, and I'm going to cut it. I think it depends on exactly where that is going to hit, because yeah. So see that's sticking out, but it's not sticking out to the point where it's inside, you know, it's sticking into that wood kind of all the way through. So we're going to go that one, we're going to pick up both of them, and then we're going to flip this around, and we're going to say to object. I'll need to measure how big this distance is. I'm just going to cut it all the way through to there. And again, it's not liking that. So this one, it does have this feature, and it says extend faces, which will let me actually cut that all the way through, even though the faces don't extend all the way through. So let's me cut that out. And that is going to be a fairly, you know, deep port, because this case is so big, so thick. But I'll measure some cables later and kind of get an idea if that's going to be reasonable. But that's 12. It's 12 millimeters. It's not. So this is 12.7 across by 8.9 high, which I think is pretty accurate for most USB cables. They're going to be within those dimensions. So I don't think we'll have a problem with the USB cable trying to fit through that port, that cutout on the side there. So you can see when you look at it from this angle, what I was talking about earlier, this is not enough room for the USB, so we need to cut out a pocket for the USB to sit in. And again, to do that, we're going to define a new sketch window that USB port turned on. We define a new sketch plane. It's going to be this inside of the case. And I could try to get this to fit real tight right around here, but the simplest thing is going to be just to define this to be the same as the rectangle that I just drew. Well, that doesn't need to be that big. So I'm going to make a rectangle. I'm going to project a couple of key points off of this connector, which are going to be the this kind of back corner here, and then those side wings. So I'm going to zoom around all over the place. I'm going to hit project. I'm going to pick up this back face. And it'll project it in 2 dimensions, of course. And then I'm going to pick up just these points. It's easier to work with. I just pick up those 2 points. Okay, now I'm going to turn that connector off. I'm going to get back on there. Turn off the case as well. Okay. So now I'm going to make a rectangle, and I want it to be attached to this line that we have here, which is the little inset. Yeah. And I want to make sure it extends around those points that I just defined. So then I'm going to make a dimension, and I'm going to say I want this from here to that point. So whatever point I picked here, it attached itself to something. I'm not sure what it attached itself to. So let me try this again. I think it attached itself to that. Okay, well that's... So on that line, okay, now I'm going to do what I was trying to do, which is dimension from here to here, and we're going to make that 2. And then dimension from here to there. All those files just hit escape a bunch of times. D for dimension, click the point, click the line. If you have something else selected, it really throws off your what you're doing. So when I was looking at this, it appeared that this one was further back than that one, but it doesn't appear to be the case now. So I'm just going to use this one as my reference. What in the world? I have no idea what I was trying there. Oh, it's a selective. I'm going to change these offsets back to 1. I don't think it needs to be that big. 1's a pretty good tolerance. So 1 millimeter all around. Stop the sketch. Now. Okay, so now we're going to hit Q again, do that, and we're going to go down to object, and we're going to pick this plane right here. And it's going to complain, but then if we hit this extend faces, it will actually let it work. Okay. So some people might object to having this little offset right here. It doesn't bother me. I'm going to leave it there. I think it's probably not a big deal. But again, you could take that out if you really cared. We'll see when we go to actually do the cutout in the CAM design. It might be beneficial to remove that. I don't necessarily have to bring that pocket for the USB port all the way down either, so that is something else. Let's do that. Okay, so let's go back in here and edit this. And we're going to change the 2 I'm going to make it be, turn off this bottom. Make the 2 be the bottom face of the USB connector. There with an additional 1 millimeter offset. So it's a -1. I never know which way this offset's going to want to go. Again, it didn't like that, so that if I just come in and change this to a distance, it'll do it perfectly, so whatever. Okay, there we go. Okay, so a couple of things we need to go start adding at this point, and that is fillets. So I can't cut this corner. So if I'm cutting from the top with a bit that's round, I can't cut it to a precise point. I have to cut it to something with a radius on it. And so I need to figure out what I want that radius to be, and that's going to be based on the tool size that I'm going to use to actually make that cut. And that's going to kind of come into play a little bit down here too with this little thing that juts out. We may have to adjust that. We'll see. So I'm going to cut this out. I'm going to attempt to cut this with a 1/4 inch bit. Because if I do that, then I don't have to, if I can get away with that, I don't have to use a sorry, just trying to read some chat messages. Okay, if I can do that, then I can, on my CNC, changing tools is fairly involved, as you'll see in a couple of weeks. So I try to avoid tool changes. So I try to get this minimized down to as few tool changes as possible. And so I would like to see one tool to do most of the work, which is a 1/4 inch, and then one that I can't really get away from, which is the 1/16 inch to carve out those little mounting holes. So when I come in here, I want to make, so I was just measuring the radius on that inside corner there, and it's a 7 millimeter diameter, which is bigger than a 6.35, which is a 1/4 inch bit. So those corners are fine. I don't have any problem cutting those. Outside corners are fine. You can round off outside corners for a couple of different reasons, just to make it easier to make it not so sharp for aesthetics and things. But in terms of the tool performance, the outside corner isn't a big deal. I might end up rounding that off just to make it easier to get this corner. But what we'll do here is we'll add press F to add a fillet. We'll add a fillet to there, and we'll add a fillet to there. And I want this to be slightly larger than a 1/4 inch. Because I don't want to jam my tool right up into that corner. I want to be able to roll through it and have it not make more contact than I want it to as it's going through that radius. So I'm going to set this to 0.13 inches. And then we're going to take a look at it, and we're going to see, yeah, it looks like that will give us plenty of clearance since we offset that thing 1.5 millimeters, so we have plenty of clearance there. And that's fine, so that should be good. Excuse me. The other thing here now is in this bottom of this little pocket here. These two back edges. I think we should have plenty of room to do the same radius on those. Change just the USB port back on, I should see that looks like we have plenty of clearance to be able to fit that thing in there without having any conflict, because I went to those outside things and not the button. So we got plenty of room there. Now what's going to happen is when we actually go to cut this out from the top, we're not going to be able to cut those sharp corners on the front. So we'll kind of cross that bridge when we get to it though. Okay. So I promised you that we were going to add a little thing for the blockers up here at the top. I'm kind of thinking about this case design now, so just a second. Okay, yeah, I think we're good. All right. So what I want to do is I want to come in and I want to add a piece that's going to sit, it's going to inlay in the top, and it's going to add those two blockers in the corners over here. So we got one in this corner, one in that corner, and we'll use these points on the PCB to reference where those need to go momentarily. So we're going to make a new sketch. We're going to make it off of this top face here. Okay. And then come in here. And we're going to do what we did earlier. We're going to cut off this line because I don't want that to be part of. So I'm going to turn this case off so I can see what I'm doing there. So this is one of the more annoying things about Fusion, and that's if you create a sketch from a face, it projects all those lines, but then it makes it where you can't see them. And I don't know why it does that. See, there they are. But when I take my hover off of them, they disappear. But now that I know where it's at, I can snap to it. It's there. It just doesn't want to show it to me. It's kind of annoying. But, all right. So I'm going to, again, make this stuff here be construction lines. I'm going to offset. Chain section. Let's see, yeah, chain section is actually going to work this time. Okay. So now I want to make sure that I have room to be able to screw this in to the edge of the case. So that's I'm going to need to leave a fair amount of space. Probably, if you think about it, I'm going to have I'm going to have 2.5 millimeters for the hole, maybe 2.3, and then I want to leave some on either side of that. I feel like 6 is probably a pretty good number to give me the spacing that I want. So we can do that. This piece does not need to be there. Okay. Actually, yeah, and then we're going to offset it. So I'm going to project these corner switches. So we want to know exactly how far out from this switch can we put this edge of this blocker so that the keycaps don't touch it. And that's going to be approximately 9. Let's see. If we go to 19, so 9.5 millimeters from here to there is going to give us. So I'm going to project that circle, and then I'm going to make a new. I'm just trying to figure out the best way to do this. Let's measure this distance from here Fusion is being extra Fusion today. Extra laggy. Probably because I'm trying to stream at the same time. Like that. My computer's not the greatest in the world. I'm just trying to get it to let me measure this. It doesn't want to. I think it doesn't like having all of these capacitors and stuff that are defined on the back of this board. It's really kind of dragging. Okay, so that's 17 from the outside. And maybe it'll let me do it from the inside. It's 11. Okay, so it's 11 from there. So now if I offset this toward the inside, I can do it 1.5 millimeters. It's kind of back to the original PCB edge. This PCB edge is kind of at the minimum as it was in the first place. So knowing that, then I'm just going to project the edge of the PCB into here, into this sketch. Now we can turn off the PCB and maybe it'll so. It'll quit being quite so ornery. Okay. So now I need to go ahead and close off this last piece here. Why is that an angle? Now then, I do need to go ahead. I do need to add the blocker pieces in here in this bottom corner. So I have to turn the PCB back on for that, because I need to know what is my kind of minimum space that I can use here. So I need to project this circle in that circle, which is going to define kind of the top of the blocker and the bottom of the blocker. Do the same thing in the, not just the bottom, the side. Same thing in the other corner. I'm going to check one thing over here, which is okay, that is a 1U. So that's what I wanted to check and make sure this, because I'm going from the center of this key, I want to make sure that it's defined as a 1U and not a 1.5 or something. So I'm going to make a rectangle. I'm going to position it here. And I'm going to put it, actually if I do it from here, it'll be easier. From there to there. And I will dimension this from here to the center of that circle. It needs to be 9.5. Same thing here. Rectangle, not dimension. Not dimension. Not 95. Okay. So the sketch is not completely defined because I need screw holes in this piece. But let's go ahead and see what it's going to look like. So we're going to get the case turned back on here. And we're going to project this piece and that piece. Making sure I've got this little bitty corner in this corner there. And we're going to bring that down. We're going to say that's going to be a 3mm piece of either brass or acrylic, whatever we end up finding there. Acrylic, obviously, for this, well, most likely for this prototype, and then if we get lucky, maybe we'll, oops, okay. So, good thing to note here. So it decided that it wanted to do that as a cut. If I cut that to the same exact size as this piece that I'm going to put in there, it's most likely not going to fit, as I mentioned earlier, unless those tolerances are just super, super precise. Which if I was going with, you know, when I get closer, if I was going to manufacture this out of aluminum and have that piece cut out of brass, maybe on a water or laser, and I could get those tolerances down to 1/10 of a millimeter, then I still would want to add some gap between the two because I just would need to add less gap. Because I can't have that be a complete, the exact same size, or it's never going to fit. So let's go back into this extrude. And we're going to change this from a cut to a new body. I'm going to deselect that. See, somehow it selected all of them for me. I don't want all these things anymore. So you see these really weird lines here. That means that there's two objects occupying the same space. And like I said, we could cut that away, but I want to make sure that it's gonna fit exactly. And I'm also trying to figure out why my extrude didn't give me what I wanted. Don't want this middle piece. I must have accidentally clicked it. I had it do this to me the other day. It did not like to make like that for some reason. So one thing I've thought about doing on the PCB was cutting out those corners of the PCB so that I could kind of make these more solid in the corners here, but I didn't end up doing that because I put some stuff in the corners of the PCB. So okay, what I'm trying to do is not make this a cut, because I think that's what's messing everything. New body. Nice. Thanks, Vision. Well, okay, I can solve this. So we're just going to do Q, and we're going to take this sketch and turn it back on. We're going to get this inside part. We're going to recut this thing. I don't know why it's... We're going to go to object. Flip this thing around so I can see the back. See the back side of that. Oh, sorry. Bodies on turn just this way. There we go. Okay. Now that we still need to cut out the case so that it's going to receive this piece, and we need to add the screw holes to mount this in there. And then we need to add a couple other nice little features to this case, and we also need a plate. We got about 37 minutes, so hopefully I can get all this done. I think we got this. So I'm gonna come back into this same sketch just to make things easier, and I'm going to offset this outside sketch, and it's going to complain, but that's all right. I'm going to give it, I want this to be a fairly tight fit, and I think I can get pretty good tolerances, so I'm going to give this a 0.5 millimeter. Usually consider means you can do anything. Okay. So it's not even going to let me do that. So I'm going to have to offset the same one that I used originally. So now I have to do math. So what I'm trying to get to is from this one here, which is at 1.5. Okay, cancel that. Stop the sketch. So when it doesn't play nice and I don't like to mess around with it too much, I'll just make a new sketch. we'll go from this piece right here. So now we have the actual piece that we're working from. And now I'm going to offset this outside curve. And I'm going to give it 0.5 millimeters. And say OK. And now, if I turn off these two bodies. So you see I have two curves. Right, I have the original and the new one. I'm going to take the original one and all of kind of these inside pieces, and I don't even have to do all of them. I'm just going to turn those into a construction plane, and now the only body or the only polygon left to find is this outside one. So stop that sketch. Turn this body back on. I don't want the insert turned back on, because what's going to happen is when I go to extrude this, when I tell it I want to cut, it's going to say what bodies is it going to cut, and I don't want to cut the one that's that I'm keeping. So do that. I'll turn it back on, and now you see all my little interference lines went away. If I zoom in real close, you'll be able to see a very small gap in between the two, but we want to have room for this to fit properly. Okay, so now the last thing that we need to do is we need to add some screw holes. So I'm going to go ahead and put those into this same sketch that I just used, and I could put these wherever. Probably want a few of them. I'm going to put let's say 3 across the top, 3 across the bottom, and 1 in the middle of each side. Again, everything needs to be well defined as to where it's positioned on the object. So I need to define some construction lines in order to position where these things are going to be. So I'm going to get rid of the, actually, yeah. So I'm going to go ahead and change the rest of these into construction lines, which I didn't do earlier. Just so that okay. Now I'm going to draw a new line, and now it's on that line, which you can't really see, but it's there. I'm going to put it here. I'm going to put one here at the midpoint of this line, because I'm right in the middle. So I'm going to put these on the outside line so that they're crossing this one. So here, make sure that's perpendicular. So it's going straight across. This one's going to be at the midpoint. That little triangle means midpoint, so that's what I was looking for. There. Okay, I'm going to make all 3 of these lines construction lines, and I'm going to define 2 more construction lines, not 3 more actually, maybe even more than that. I have a mouse turned on somewhere. Let me check my bag. I've had this happen to me before. You get really, really weird mouse behavior, and it turns out that in my bag I left my mouse turned on, but that does not seem to be the case here. So it's just Fusion being weird. Okay. Okay, another one that's going to go. So there's a line here, and here if I don't necessarily need to go from the midpoint of that to that line. There's a line there that I can't see, and I wish there was some way to change that in Fusion. I haven't found it. If you know what that is, then please let me know. So you notice that some of these lines are black, and some of these lines are this orange color. The orange color means that they're not defined where they are, and so I can move them. If I get this black line, I define it to be the midpoint, so I can't move it. It's completely well defined. So I want to try to get everything to be black. So there's some different ways you could do this, but the easiest one to do what I want to do here, which is to make this line be exactly the same distance between these two lines, is to use this symmetry. So I'm going to say this line and this line are symmetric about the center line, and that defines that symmetry. Do the same thing over here. This line, symmetry. And then do the same thing here for these two side lines. These are going to be the center lines for my screw. Okay, now this one is going to be the center line for the screw, but can't. I'll see when I get to it in a second. I may need to draw another line on each of those sides. So again, we're going to draw some screw holes here. I'm going to draw two sizes of circles because I want to be able to use these for both. I use the same sketch for both the hole in the wood side is going to be 3.1, and the hole in the top piece is going to be 2.3. Okay. Oh, so it didn't actually take those dimensions. Go back and use hole size. So because I didn't hit enter on those earlier, it didn't actually take those. Let's do the same thing across here. We're going to find two circles. One's going to be 2.3. If I hit enter, I'm going to accept that, and then this other circle is going to be hole size. It's not picking the bracket pane. That's the problem. This is going to make it a little bit difficult when I go to do this later, but it makes it easier to not have an extra sketch. It's going to make it a little difficult to select the one I want, but otherwise I have to make two sketches and project points, and it's just extra steps. So just a little zoom in to pick the point. Okay, so this is the one question I'm not sure about here. I think actually I want this to be at the midpoint of this line, so I'm going to just make the circle at the midpoint of the line. Should be good to go. Probably should find the parameter for the 2.3. I'm just going to do that later. Kind of tend to define parameters for something that I'm going to use over more than once like this, or something that I may end up changing in the future. Like a lot of times I'll set parameters for the different offsets and things that I use to make sure that I can easily go change, say, the thickness of the case, or the how high it is on the sides for a high profile. One more. Okay. Now it was defined. Back on, turn the sketch back on. Now, I'm going to grab the inner holes. Going each of the inner holes, we're going to cut these holes in this top piece. Okay, and now we're going to do something here. So we're going to turn off this case, and we're going to tell it I want to go through everything. Sorry. Through everything. Okay, so again, as long as I don't have everything open, then it's going to just do this piece. Okay, and then we'll do the same thing. We're going to hide this one, show this one. This time we need to go in and we need to pick not just the inner one, but the inner one and the outer one. My computer's really dragging Fusion here. Starting with lots of fairly complex modeling. Because I really have to turn that off so instead of doing it here. Missed one. Good. Okay, now this time we can't use all, but we don't want to start at the profile plane. We want to start at this upper surface here. I think I got the right one. It's hard to see on that. With that one, we want to go down 3. I like to go a little bit more than 3 so that they make sure and sink all the way in, 3.2 millimeters. Cut those things in. Okay, so now we have holes around the edge, which are going to be really kind of close, but hopefully that won't be a problem when split the wood. We'll see. And then turn the top piece back on. We can give these things some names now. So this is going to be our case. This is going to be our top. And then I like to create these into components so that they're kind of top level components here. I normally would have done that a long time ago. I just kind of forgot, but it doesn't really matter. You can do it anytime. I'm going to take this. Okay, so we're starting to shape up. One thing we're missing is a plate. There's several ways to do that, obviously. I could come in here and I could model that myself, which I'm not going to do. Or, you know, I can do the easy thing, which is to go over to builder.swill. Right, so I'm going to go, this is my raw data. I've gone in and I've added the extra keys. I went and kind of did some math and came up with two 275 keys, a 1.5 key, and another, the other 275 make up a 7U space bar, keeping the center thing in the middle with keys that are easily available. I'll probably pick up some blanks from either my grab bag or some from P&K. A lot of sets may or may not come with 2 of these, and they're probably not going to be blank, but you can find some set that's going to cover this. Or you can use your 7U space bar, which most people that are going to do HHKB layout are probably going to use that. I did drop the split backspace up here. Sorry, excuse me, I dropped the full-size backspace. I left only the split backspace just to kind of simplify the PCB design. So we can capture all this. We get the raw data, come over here, we drop it into Swill. The key thing to note here is that I want to turn key unit size to 19 because that's what I used when I defined that, if you remember back to last week. Okay. The other thing is I don't care about switch top removal because this is a hot swap board, so I'm going to use square ones and make it nice and easy. I don't care about any of these other features because I'm just using this to get the layout, and you'll see in a minute I'm going to actually define the edges of the plate myself. So this is all I need. I don't need any holes or anything like that. I just need the switches themselves. The outline doesn't matter. I'll take it away. Okay, so that is what it thinks my plate needs to look like. That looks about right with the 2 different sets of stabilizers down here on the bottom. Probably look pretty well. So I'm going to get the the DXF for that. I don't like SVG bringing that into CAD. It's never accurate. So I'm going to use the DXF. Okay, so I'm going to define a new sketch, and conveniently enough we have a construction plane for the top of the plate. So we're going to do that, and we're going to, oh wait, sorry, not define a new sketch. We'll insert the DXF, which will define a new sketch. And I will use the plane definition as the top of the plate. Select the DXF file that I just downloaded. Think about life for a few minutes. And of course I have to move it. Isn't that nice? It should be centered on the origin. think that's right. I'll have to check. So if I turn the top case off, if it's just the PCB, doesn't have to be super precise. I mean, I want it to be, yeah, so this looks like the right. You know, it looks like it's shifted a little bit to the left, doesn't it? And I'll fix that here just in a minute, I think. It's not really possible to do that here in this sketch because everything is not well defined. See, I can just drag that, so I don't want to do anything in here to jeopardize the integrity of that. So I'm just going to bring that in, leave it as is, and I'm going to extrude the plate. So we were defined on the top of the plate, so we're going to go minus 1.5. Assuming this is going to be a metal plate, we may end up getting it cut out of acrylic, but for these purposes it really doesn't matter a whole lot because of the way this case is going to go together. So we'll just leave it as 1.5 for now. Okay. So I have a plate. That plate needs to have holes in it, and those holes need to line up with. We need to move this over, didn't we? So we need to shift it over just a hair, and now's the time to do that. And we need to add some nice rounded corners to it because I don't like plates with pointed corners because they can catch you and among other really obnoxious things. So I wanted to shift this over. Alright, so we can measure this, so we can say, okay, pick this face, pick that face, we made 0.091 millimeters. We're going to do the same thing on the other end. Then make sure you get the face, because if you pick the edges, it's going to get a different dimension. So that's 0.092, presumably in the other direction. So if I remember earlier, it needed to go to the. I'll just pop back in the sketch and see. It needs to go to the right. So we're just going to move this. Grab that. Sorry, Fusion is spazzing out on me. X distance is going to be 0.091. Okay, just a little nitpicky thing. Now then, we're going to make another sketch, and we're going to project some circles onto it from the bottom. So I'm going to go ahead and turn off the plate and project these circles. Actually, I've already got these on this other sketch, so I can project them from the other sketch. It'll be easier. Just turn off the PCB. That's the original sketch. And I want to project, it doesn't really matter, let's project these. We can drop bigger ones anyway. I'm not sure exactly how big I want to make them for a screw hole. Actually, yeah, I'm sure. Okay, because the PCB is mounting to is a hot swap, that kind of changes the normal behavior of what we do with the mounting. So in the normal case, the case mounts together one of two ways. Either the PCB mounts to the case and the plate is held in place by the switches and floats on top of it, or the PCB floats underneath the plate and the plate is attached to the case. That's typically you have one of those two options when a case is put together. Sandwich case being PCB plate supported with a PCB dangling. That's the same thing with some of the top mount customs. The PCBs in those are not normally screwed down. Same, and then similarly on the sandwich cases. I mean on the tray mount cases like the GH60, poker, those type of things. The PCB is screwed down to the case, and the plate just is held in place by the switches and floats up above. When you have a hot swap case, a hot swap PCB, you can do one of those two options, but if you do a floating PCB, when you put a new switch in, it's going to push the PCB down. And similarly, if you have a floating plate, you run the risk of pushing the plate down when you are swapping your PCB. When your switch is out, if you take too many out at once, and it makes it kind of difficult to assemble. So we want to have both the PCB and the plate secured to the case, and that kind of complicates things when we're mounting this. So the solution that I'm going to be using is I'm going to have the PCB screwed down to the case. You'll notice that I didn't make any mounts in this design. I'm going to be using 3mm standoffs to hold the PCB 3mm above the floor of the case, the inside bottom, true to fine. And then I'm going to be adding some additional 3mm standoffs on top of the PCB. Unfortunately, it needs to be 3.5mm, so my plan is to get some 0.5mm fiber washers, put those below the standoffs, and then screw the plate into the top of those standoffs. So we're going to have standoff PCB, washer, standoff plate, and then the screw in the top of that. So I'm hoping that this design will work. I've played around with some other options. The other option is to mount both the PCB and the plate to the bottom by having holes in the case, in the PCB for standoffs to pass through, but that gives me more holes in the case that I have to then put threads in, and I'm hoping that I can avoid that. So we're gonna play around with this. We're gonna hope it works. But for now, what we need to do is we need to find our plate, which we'd like to rename and convert to a component. It's easier for me to find. And then I want to cut holes in the case, same size as the ones in the PCB. So I'm going to turn off the top of the case for now. So see what I'm doing. Okay, so this particular, I didn't think about this when I was designing this screw mount. It's going to be where the standoff wire goes. So the plate will not have that screw. The PCB is only going to be mounted to that screw. That's fine. Luckily, none of the rest of these run into that problem. I think I'm misprojecting some. What's going on? Yeah, okay. I'll come back and grab those for a second after I finish this. Okay, so now I want to go down, and I'm not going to go that way. I'm going to go to the bottom of this object. So I'm going to turn both the sketches off. To object. Okay, like I said, I forgot a couple of holes when I was projecting these. I forgot those two over there on the right for some reason. So now I'm going to project that off the sketch again. Okay. And then I'll go edit this extrude here. Okay. We've got holes. Like I said, I'm going to add some curves to these corners, and then I think one thing I'm going to do is add some fillets onto these blockers here, just to kind of give it not sharp edges. That's the basic design, and I could stop right there and probably have pretty good case. But let me go ahead and tweak these couple things and then show you one more. Well, yeah. So tweak these couple things and show you one more thing, and we'll wrap up here in the next 5 minutes or so. So I'm going to grab this edge, and this edge. And I'm just going to put a little bit of a radius on it, just 1 millimeter. Actually, go ahead and grab them all at once. This one, this one. Okay, so that's that one, and then the last one was the plate. We'll do the same thing. Again, just grabbing these 4 edges right here in the corners. Just kind of eyeballing it for now. Just something so they're not completely sharp. Okay. Always good to save every once in a while. Fusion does auto-save. KiCAD is the one you have to be careful about saving all the time because it has a tendency to crash and it does not auto-save. Well, it does, but when it crashes, it never has what you wanted in the auto-save. Fusion is usually pretty good. If it crashes, then you probably have the file you wanted in auto-save. Okay, so 2 more things we need. I want to send these. I want to send these 2 pieces off. On this top piece and this in this plate. I want to send those off to be manufactured. Either I'm going to send those over to Jordy at Strata Keyboard and have them laser cut out of acrylic, or I'm going to send them off to one of my other shops and have them laser cut from stainless or brass or whatever. So, or water jet cut or whatever. So, I don't want to use one of these ugly sketches that I had. I want to use a sketch that is just has the curves I want. And luckily, Fusion makes that really simple. What I like to do is I want those sketches to be defined as part of this component. Let me grab this sidebar over here. So if I go to this menu tree over here, and I click on one of these components and I say activate, then any new sketches I make will be defined as part of this component. They'll show up underneath it in the tree. And that just kind of helps keep it from confusing it with other things. So I'm going to create a new sketch. I'm going to pick the surface of this plate, and it picked all the points for me. And all I have to do is hit stop sketch, and I can now go in here to sketches, and I have this plate sketch, and I can export this, save it as a DXF, and ship that out for production. So I'm going to do that. Go this into my Woodkeys directory, and I don't have a folder here, so I'm going to make one. I gave this one a name. I gave this keyboard a name. I called it Shadrach. I went to my name generator that I like to use and typed in something because it has arrows, and I typed in arrow or straight or something like that, and it said, well, I didn't find a name that meant that, but I found one that kind of looks like that, and I liked it. If you're familiar with the story from the Bible, the Shadrach, Meshach, and Abednego. So we're going to put it in there. We're going to call it plate. And then I'm going to do the same thing. I'm going to activate the top component. I'm going to make a new sketch on the top surface. I'm going to stop the sketch. And I'm going to export it as well. Okay, so that's it. I have a case that is, 99% ready to be manufactured. I'm sure there's a few other things that I would tweak along the way, but that's by and large the main thing. We'll make those tweaks when we actually go to do the cutting of the case in the next episode 2 weeks from now, unless the PCBs don't come in time, in which case it will be next week. So plan on coming out for that. I guess I could open it up if anybody has any kind of questions, throw those in the chat, and either YouTube or Twitch, and I should be able to see either one of those. Any questions? Going once? Going twice? Okay, I'm going to sign it off. The stream will be up on YouTube if you're missed part of it. It should be up within the next short few minutes. So y'all have a great night.